We'll now look at two particular types of series, an infinite series in particular. So we'll look at a geometric series and a telescoping infinite series. So first is the geometric series. And this is if a is not equal to 0 and r is real numbers, then we have this sequence, the sum from k equal to 0 to infinity of a times r to the k is equal to a over 1 minus r, provided the absolute value of r is less than 1. If the absolute value of r is greater than or equal to 1, then this series will diverge. So for example, we have the summation from k equal to 0 to infinity of 1.5 to the k. And we know that the absolute value of 1.5 is greater than 1. Therefore, this series will diverge. Next, we'll look at the series from k equal to 0 to infinity of pi to the negative k. So the first step is to realize that this is actually the series from k equal to 0 to infinity of 1 over pi to the positive k. Since a negative exponent just means we move it to the bottom of the fraction. Since 1 over pi does have an absolute value less than 1, this thing will converge. In particular, a, which in this case is just 1, over 1 minus r, which is 1 minus pi. And if you simplify this, you get pi over pi minus 1. We'll do another one. And here we see that the absolute value of negative 0.7 is less than 1. So therefore, we know that the series from k equal to 0 to infinity of 4 times negative 0.7 to the k is equal to a, which is 4, over 1 minus r, which is negative 0.7. So this is actually 40 over 17. However, you'll notice this is not the series, because this one in particular started with k equal to 2. This one starts with k equal to 0. So if I want the one that actually starts at 2, I'm going to have to modify this slightly. In particular, I'll take the series that starts at 0, and then I'll subtract out the 0 case, since we don't want to include that. And I'll also subtract out the 1 case, since we don't want to include that either. And now we're actually starting at 2. So next is a telescoping series. A telescoping series has successive terms that cancel each other out. So for example, here, if I look at the nth partial sum, Sn, then I'm going to start with k equal to 1 and have 1 over 4 minus 1 over 4 squared. So this is k equal to 1. K equal to 2 has 1 over 4 squared minus 1 over 4 cubed. Here's k equal to 2. K equal to 3 has 1 over 4 cubed minus 1 over 4 to the 4th. Here's k equal to 3. And we can continue this up until the nth term, which is 1 over 4 to the n minus 1 over 4 to the n plus 1. And you'll notice here that I have negative 1 over 4 squared plus 1 over 4 squared, negative 1 over 4 cubed plus 1 over 4 cubed, negative 1 over 4 to the 4th, the next term will be plus 1 over 4 to the 4th. And in general, everything cancels but 2 terms. So whenever we actually want the series, we actually want the limit as n goes to infinity of our partial sums. So we have 1 over 4 minus the limit as n goes to infinity of 1 over 4 to the n plus 1, the two terms that don't cancel. We know that the limit of 4 to the n plus 1 as n goes to infinity is infinity. However, putting this on the bottom of a fraction would go to 0. So my actual series is 1/4. This one will require a little bit of work beforehand. In particular, we need to solve the partial fraction decomposition in order to make it look like a telescoping series. If I multiply by the denominator, I will get 1 equal to a times k plus 1 plus b times k. If we let k be equal to 0, we'll see that I get 1 is equal to 1a. And if k is negative 1, we have 1 is equal to negative b. So b is equal to negative 1. And now this series is a little bit easier. So we have that the series from k equal to 1 to infinity of 1 over k minus 1 over k plus 1. So we want the limit as n goes to infinity of our partial sums. So this is the limit as n goes to infinity, and we'll start sticking in terms. If I stick in 1, I get 1 over 1 minus 1 squared. If I stick in 2, 1 over 2 minus 1 over 3. If I stick in 3, 1 over 3 minus 1 over 4, etc., until I get to my nth term, 1 over n minus 1 over n plus 1. And once again, we have negative 1/2 plus 1/2, negative 1/3 plus 1/3, negative 1/4 plus 1/4. And we'll have all but two terms cancel, the first and then the last. So the limit as n goes to infinity of 1 over n plus 1, which is 0. So this series is 1.